Good afternoon, madam.
Good afternoon, sir.
How are you, madam?
Doing good, sir. How are you, sir?
Fine, madam. Fine, madam.
Are you able to hear my voice clearly?
Yes, madam. Yes, madam. I'm able to hear, madam.
Okay. Okay.
Can you share one? Can you share one PPT, madam?
Here I'm getting the host disabled participant screen sharing. I think you have to allow me. Somebody has to give permission.
Just 1 minute, madam. 1 minute.
Okay.
Now you can share it, madam. Post.
I'm unable to share, sir.
Yes, madam. Now we are able to share, madam. I given the post.
So, do you able to see my screen? The slide?
Yes, ma'am. Blockchain you use cases. Yeah, no problem, madam. Afterwards, you can do the full screen, madam.
Now, sir.
Yeah, now it's okay, madam.
Okay. Okay.
Okay.
Should I switch on video for the whole session?
Yes, madam. Yes, madam. Yes, madam. Just 5 minutes you can sit down.
Okay. Whole session or 5 minutes? Just 5 minutes.
Just return back to me the host, madam. Just return back to me host and
I will stop share.
yes. Huh? Hello, Miss Kavya?
Yeah. Is my voice is audible?
Yeah. Now we can start the meeting.
Okay. Okay, fine.
Yeah.
Yeah. Namaste. Happiness can't be behind sorrow. It's your choice to make a better tomorrow. Enjoy this beautiful day with a lovely smile. A very good evening to everyone who confers here. It's a pleasure to meet you all at this wonderful program today. Ladies and gentlemen, on behalf of the National Design and Research Program, NDRF, the Institution of Engineers India, I'm your host for this evening, Kavya. And I extend a very warm and hearty welcome to each one of you all here. It's a beautiful evening. Well, first most, I would like you to thank you all for taking the time out of your busy schedule to join us today. It's a pleasure to have you all here. Can I continue? Hello, sir.
Kavya, your audio is not hearing.
Okay, it's not proper or you couldn't hear us. Hear me. Okay, one sec. Sir, can you hear me now?
Yeah. Kavya,
Kavya, your audio was fine. Go ahead.
Hello, sir.
Yeah, Miss Kavya, your audio is fine. In between, there was intermittent disturbance. Now it's fine. You go ahead.
Hello, sir. Sir, is that audible now?
Yes.
Okay. Can I continue? Or can I
Please proceed.
begin from start? Okay, sir. Namaste. Happiness cannot be behind sorrow. It's your choice to make a better tomorrow. Enjoy this beautiful day with a lovely smile. A very good evening to everyone who confers here. It's a pleasure to meet you all at this wonderful program today. Ladies and gentlemen, on behalf of the National Design and Research Program, NDRF, the Institution of Engineers India, I'm your host for this evening. This is Kavya, and I extend a very warm and hearty welcome to each one of you all here. It's a beautiful evening. Well, firstmost, I would like you to thank you all for taking the time out from your heavy schedules and making this spectacular evening with your glorious presence. Thank you so much for coming tonight. Thank you. Ladies and gentlemen, we all know that why we have been gathered here for, of course, we have something very special in hand with us. So it is very special, good news. We can say that it is the second day of 14 days of the online intensive program. This pandemic world has made us conform and learn online. So here it is a golden opportunity given by National Design and Research Program NDRF, the Institution of Engineers India. The NDRF intensive program is presented in association with IEI Kanpur Local Center. It's my pleasure to announce that the topic for today's thread is blockchain and Internet of Things, which is nothing but IoT. In a gesture of gratitude, I would like to announce Dr. P. Kalpana ma'am, Assistant Professor, Indian Institute of Information Technology, Design and Manufacturing, Conchipuram, as the speaker today. I encourage all the participants to put their questions in the chat box of our YouTube channel. We will take the questions from there, so please do not stop posting your questions. Now, I am pleased to introduce our speaker. Dr. P. Kalpana Pichaimani, currently working in the Indian Institute of Information Technology, Design and Manufacturing as Faculty of Mechanical Engineering. Her previous positions include Deputy Manager, Optimization Specialist at Ford Motor Company and Operations Research Consultant for Ramco System. She did her PhD in the area of Operations and Supply Chain Management at the Indian Institute of Technology, Madras. Her interests include solving interesting problems in the area of supply chain management, scheduling, logistics and transportation, inventory planning using mathematical modeling, algorithms, heuristics, meta-heuristics, and simulation techniques. Currently, she is focusing her research more on supply chain management, Internet of Things, and blockchain, advanced optimization techniques, and artificial intelligence and machine learning. Now I welcome Dr. P. Kalpana ma'am for the technical session to address her lecture. The virtual stage is to you, ma'am.
Good evening, all. Thank you for your nice introduction.
Thank you, ma'am.
Yeah. Shall I share my screen?
Yes, ma'am. Sure, ma'am.
I am unable to share my screen. I think you have to give permission to me. Hello, can you hear me?
Yes, ma'am.
I am unable to share my screen.
Kavya, please return back to the host to the Kalpana madam.
Okay, okay, sir.
Kavya, in the participation list is there, no? 1, 2, 3. Yeah.
Yes, sir. Yes, sir.
Yes. Now we can share, madam.
Do you see my screen, sir?
Yes, madam.
Yeah.
Please do the full screen, madam.
So I have put in full screen. Should I switch on video or is it okay?
It's okay, madam. No problem. No.
Okay. Yeah. So good evening, everyone. So today my topic of presentation is IoT and blockchain, the emerging technologies transforming the world. So already Ms. Kavya has given about the introduction about me. So I will start from this slide. So in this slide, you can see this is the statement was given by our Honorable Prime Minister, Mr. Narendra Modi. So he said, emerging fields including artificial intelligence, machine learning, Internet of Things, blockchain, and big data can take India to new heights of development and improve the quality of life of its citizens. This is not just an industrial transformation, but a social transformation. He also added the new technologies, including Internet of Things, blockchain, will help India to address challenges in education, healthcare, agriculture, job creation, and environmental sustainability. So with this statement, I will start my presentation. So today we are going to talk about the Internet of Things, or in IoT, or it is otherwise called as Industrial Internet of Things, or IIoT. So these are the two leading terms which is predominantly used in our digital world. And so after this, we will talk about the blockchain technology, which will enable the Internet of Things to operate in a more secure way, and followed by a data analytics. The role of data analytics in Internet of Things. So we cannot separate data analytics from Internet of Things. Okay. So actually, this term Internet of Things, which was coined by Kevin Austin in 1999, but the concept of, so the Internet of Things is nothing but connecting devices through internet. Okay, so which will enhance the business process and which will improve the efficiency of any business process. And so the actual concept is connecting devices through internet, but the concept of connecting devices or machines have been around a long time before. Since 1830 itself, we are able to connect machine to machine communication. One of the example is electrical telegraph, and we can say that Wi-Fi or radio voice communication. So these are some of the technologies which connect machine to machine, which connect things and which enables machine to machine communication. Okay, and so before going to discuss more about Internet of Things, actually I'm not going to talk about the technological stack behind Internet of Things and blockchain. So in this session, I'm going to talk about the basic concepts of Internet of Things and Industrial Internet of Things, and what are the challenges? Currently the Internet of Things are facing, and what are the various domains which apply Internet of Things, and so what are the technological needs to improve the functions of Internet of Things. And one such technology is blockchain technology, and we are going to discuss about the basic concepts of blockchain, and how the blockchain works, and what are the complexities of blockchain, and various domains in which both IoT and blockchain can be applicable, and followed by the role of data analytics in both these two. So I'm going to restrict my presentation only on this. So, so before discussing about Internet of Things, first let us discuss about the Industrial Revolution to look at how the Internet of Things is positioned. Okay. So in this picture, you can see the Industrial Revolution. Actually, the first Industrial Revolution started in 1784. So before that, actually people were developed the products by using hand tools and handicraft methods. So they will have a small shop nearby house, and they will do the entire fabrication of the product. So during that time, the production quantity of the product was very, very less. And over a period of time, the population gets increased, and the need for the product gets increased. So the products developed by handicraft methods were not unable to satisfy the demand of the customer. Okay, so the concept of, then they go to the concept of outsourcing. Okay, so later on, the concept of factory came into picture. So factory is the largest site where people were hired to produce, they were involved to produce products. Okay, in case of handicraft methods, suppose if you take to make a product, if we need some 15-20 activities, in handicraft method, the entire activities will be done by the human, the person who is managing that particular workshop will be done. But during the in the factory concept, the activities to produce the product is split into small activities, and each employee is assigned to perform a particular activity. Okay, so during the first Industrial Revolution, the steam-powered engines were invented, and which increases the production quantity, and which improves the performance of the manufacturing facility in terms of reducing cost, producing more quantity of item with high quality, and to satisfy almost all customer needs. So one such example is the steam-powered weaving loom. It produces more than eight times of the production quantity of the existing machine which were operated by human. Okay, and then later on, the second industrial revolution started in 1870. So look at the difference between the first industrial revolution and second industrial revolution. So it is almost 90 years, right? And so after so during the second industrial revolution, the electrical power were discovered, and the electrical powered machines were invented. So which enables the production system to produce a mass production. Okay, so the main objective of industry 2.0 was to satisfy all customers' demand, but they didn't give much importance to produce variety of products. So they only concentrate on producing a huge quantity of items. And one of the contribution during the second industrial revolution was Henry Ford's moving assembly line. Okay, and later on, in 1969, the third industrial revolution started. So in this case, slowly automation comes into picture with the help of programmable logical controllers and computer algorithms. So initially, some of partial activities were automated, and later on, many of the companies are completely automated. So with the help of robots. For example, see, the robots has a sequence of predefined instructions. So based on the instructions, the robots will work on. And generally, this automation is predominantly used in tasks where we are doing repetitive tasks, or where we are finding a risk if we deploy human beings. So in such cases, the automation or robots were deployed to increase the production of the system. Okay, now we are in Industry 4.0. So this is mainly characterized by information technology and communication devices. And so here, Internet of Things is the key enabler for Industry 4.0. So which will connect machines or all parts of the industry, and which enables the communication between devices, and the data whatever we are retrieving from each and every entity of a factory or manufacturing facility will be used for making more informed decisions or fact-based decisions. Okay, so one such application is digital twins. So now we are able to exactly replicate the factory with the help of IoT, and without actually deploying the resources for doing many experiments. With the help of digital twins, we can do any kind of experiment. Okay, so now this IoT plays a key role in Industry 4.0. So now we are going to talk about what is IoT. So in this slide, you can see the various components involved in Industry 4.0. So autonomous robots, simulation, system integration, Internet of Things, cyber security, cloud computing, additive manufacturing, augmented reality, and big data. See, these are the components constitutes in the Industry 4.0. So now we are going to discuss about what is IoT. So before that, let us take a small example. So now most of us have smartphone, right? So why do we call that as a smartphone? What is the specialty in that phone? So we are having a we are saying that I have smartphone, right? So what is the specialty in smartphone? When compared to the existing 10-15 years back, we had a mobile phones. So in that mobile phone, we are able to only communicate. We can call. We can only call to other persons, or we can send some text messages. But now, with the help of our phone, we are able to do all activities. So we can send voice messages. We can send image files. We can send video files. We can watch movies. We can see news. So the entire world, we can bring the entire world into our palm. So the thing becomes smarter when it is connected to internet, right? So IoT works on the same basic principle. So it connects objects and devices and becomes smarter by connecting these devices through internet. And the main purpose of connecting devices or objects through internet is it enables communication between devices. So now we can ask a question, why should we enable a communication between devices? So the main purpose of connecting devices as well as enable communication between devices are collecting data and sharing data. And what is the purpose of collecting data? There are two purposes. One is to do automation. The second thing is decision making. So with the help of IoT, we can collect a huge chunk of data. So with the data, we can do any kind of decision making. We can do predictive analytics, and then we can take decisions more proactively, and we can do automation. So one such example is, suppose if you're manufacturing, you're running a manufacturing facility, and your manufacturing facility is completely embedded with IoT sensors, right? So with the help of IoT devices, you can continuously able to retrieve data from the machine, and you can continuously monitor the machine's performance. Suppose if you find if there is any abnormality occurs in the operation of any machines, immediately the algorithm which you have written to identify the abnormality will send signal, so that the operators, the concerned operators, it will send alert to the concerned operators, and the operators will come to that particular place and they will resolve that problem. Okay, so this is the main purpose of collecting data. And some of the other examples of Internet of Things are connected appliances like smart microwaves. So now we are able to just we can give a raw material and we can choose some options. You can cook the food from remote. Okay, and self-driving cars. The second application is self-driving cars. So here there are two things. So one is self-driving cars or autonomous vehicles, or you can call it as a connected vehicles. The other kind of self-driving car is rental cars. Self-driving rental cars. You can call it a self-driving rental cars. One example for this self-driving rental car is Zoom cars. So in both these cases, Internet of Things plays an important role. So if you take a connected vehicle or autonomous vehicle, the crucial parts are embedded with the sensors, which will continuously monitor the performance of the devices in terms of measuring pressure or temperature or some other physical parameters. And if there is any abnormality occurs, immediately it will alert the driver. Immediately it will alert the vehicle's owner, and immediately we can resolve the problems. The second thing is rental cars, self-driving rental cars. It is one of the business model nowadays people are adopting. So in this case, the car owners, some of the car owners may not use the vehicles for a prolonged period of time. So they usually rent the cars to this kind of companies. So they will release the cars, and people or customers can rent the cars, and they can do self-driving. Okay, so in this case, the owner is a different person, and the person who is renting the car is completely unknown to the owner of this particular vehicle. So in this case, the concept of connected vehicles comes into picture. Here, the complete most of the devices are completely connected with the IoT devices, and this system will continuously monitor the behavior of the drivers. So how he is driving, so how frequently he is using the brakes, and how frequently he is using the steering, and how much speed he is driving. So all these parameters are retrieved from that particular vehicle, and it will be sent to the company, and with the analytical tools they will give warning to the drivers. Okay, so this is how this concept of IoT is used in this self-driving rental cars and autonomous cars. And wearable health monitoring. So one such example is fitness band, right? So it will continuously monitor our daily activities. So whatever activities you are doing, it is continuously monitoring. It will give you your heartbeat, heart rate, and then it will give you the information about how much time you are sleeping, and how much time you are walking. And so all these informations will be collected and will be given to you by using this kind of wearable health monitor system. So nowadays we have systems like after receiving all these information, there are systems which will suggest. So based on your body condition, it will suggest you some kind of diet plan, and if there is any abnormalities happens in your heart rate or some other physical parameters, it will immediately intimate you. And then smart factory equipments, wireless inventory trackers. So this is predominantly used in all industries. So without human intervention, we can continuously track the inventory of any warehouse. but many of the manufacturing industry has not adopted it. Slowly, some of the manufacturing industries are adopting this wireless inventory trackers. And then biometric cyber security scanners, and then shipping containers and logistic tracking. So this we will discuss in detail in the upcoming slides. So these are some of the examples of Internet of Things. So now we will see how IoT works. So generally, IoT has 4 layers. Okay, so this has sensor layer, network layer, platform layer, and application layer. So sensor layer is the first layer. So in which the sensors may be used to measure humidity or pressure or temperature or a movement of an object. So any kind of physical parameters can be sensed by the relevant sensors, which will be embedded into the physical devices that we want to get information. Okay. Then the information collected from the sensors will be sent to this platform layer. This is the third layer, to the platform layer through this internet network layer. And so in platform layer, we have either we can use it for storage, or we can do any kind of computations, or we can do analytics, and with the help of appropriate softwares and computer algorithms embedded into the cloud computing. And the last layer is application layer. So after doing this computation and analytics, the results will be sent to the particular application layer. It could be a apps, or it could be a web services. So from sensor layer, the information is taken, and processing is done in the cloud storage, and computations and other processing and analytics are done in this platform layer, and the respective results will be sent to the corresponding application layer. Okay, so here you can have any kind of application. You can monitor environment, or you can monitor health, or you can monitor the traffic condition with the help of IoT remotely. Okay, there is one more term is called gateway that we will discuss in the next slide. So here we said that the data are collected from sensors from various physical devices, and the data whatever we are collecting is an analog form. We are measuring temperature, we are measuring pressure, or motion of a particular object. So we are measuring all these physical parameters which are in physical form, and we cannot directly store all this information in a analog form into the cloud. So the data whatever we are retrieving from the physical devices should be aggregated, and it should be converted into a digital form. So then only we can store it in the cloud. So for that, we need a system which is called a data acquisition system. So the analog data, whatever we are retrieving from the physical devices, will be converted into a digital form. And through this Internet of Gateway, the converted data is transferred to this cloud storage through Wi-Fi or wired LANs or internet. So the main purpose of this Internet of Gateway is receive the aggregated data and relay the data to the corresponding cloud storage. And then finally, it will go to the particular application or web services. So the summary of this IoT is it has 3 devices. One is physical objects, where the actual sensors are embedded to receive the data in terms of, it is in the form of analog data, and then through digital acquisition system, the data is converted into digital form, and then finally through gateway, the data is transferred to the cloud via internet. Okay, and this IoT can be classified into any of the following categories. The first thing is things that receive data and act on it. So there are some objects which receive signal from the internet, and based on the instruction, it will act on. Some of the examples are 3D printers, wearable devices, smart TVs. So you can operate the smart TVs remotely from. You need not be there in the home. You can operate it from anywhere outside the home, right? And the other classification is things that gather information and send it. So in this case, the sensors like motion sensors or moisture sensors or light sensors. So these sensors collect the data from the respective devices, and it sends those data to the cloud for decision making purpose. Okay, And the last classification is things that can perform both functionalities. So it can collect data and sends to the cloud. Similarly, it can receive the data, and based on the activities or instruction, it can act on. So one such example is smart farming. So in this case, the information like moisture from the soil and the humidity, all those information and the stages of crop growth, all these information will be collected and sent to the cloud or the web service. And based on the decision, suppose if the moisture content is not enough for that particular day, so immediately it will receive the instruction from the other side, and based on that it will increase the moisture content and it will enable the particular activity. So now we will see what is IIoT. This is otherwise called as Industrial Internet of Things. So this is the key technology in Industry 4.0. So this mainly emphasizes the integration of smart manufacturing machineries, AI-powered automation, interconnectivity, and advanced analytics. So this mainly enhances the machine-to-machine communication. So this is the important point. This enables machine-to-machine communication. Because of this machine-to-machine communication, we are able to access a greater amount of data with more efficient and faster way. And at the end, the main objective of collecting the data is by using advanced analytic techniques like artificial intelligence and machine learning, we are able to get insights about the performance of that is current performance of the factory or manufacturing facility. And by using the data, we can optimize the existing process, right? And we can predict the events which will happen in future. So based on that, we can do proactive decisions. Okay, so these are the things that we can obtain from using data analytics on the whatever the data we are receiving from IIoT. So this is not only used in the manufacturing side. So this will also used in the customer side also. So one such example is one of the famous tire manufacturing company, Michelin. So now they have introduced the concept of IIoT for which is the replacement of their traditional testing procedure. So now they have embedded sensors, pressure sensors into the tires, and during the test within their facility as well as post delivery also, they are retrieving the data from the tires, right? And based on the data, they will do analysis, and they will as a part of their service, they are giving training to the drivers, so how to operate, how to drive the cars, and how based on the road condition, how to drive the cars, in which speed they have to go. So all those trainings will be given to the car drivers. So post delivery also, with the help of IIoT, manufacturing facilities are supporting, right? So overall, with the help of IIoT, we can improve the safety, cost savings, we can improve the productivity and efficiency, and we can obtain streamlined operations. So with the help of proactive decisions, whatever we are taking with the help of data analytics, and with the help of a huge amount of data, we are able to reduce the downtime. So with this, we can save millions and millions of dollars. Okay. So now we will quickly see what is the difference between IoT and IIoT. Okay. So both terms are quite similar, but there is some small difference between IoT and IIoT. So this IoT is predominantly used in household and commercial sectors, such as home appliances, wearables, phone wearables, etc. But IIoT is mainly used in industrial sectors. It is mainly used in heavy machineries, transportation, smart cities, automation of any industries, factories, and healthcare. Okay. And the devices are the sensors, the hardware devices which enable the machine-to-machine communications are more delicate in IoT. But here we are using a more robust hardware devices in IIoT. So the reason for us, we are using the sensors in heavy machinery. So the sensor has to withstand for high vibration and high temperature, right? So we have to use the robust sensors in IIoT. And in IoT, the main objective is to increase the efficiency, improve the health and safety, and create improved customer experience. So this is the main objective of IoT. So to improve the customer experience, we are using IoT. But in this case, this is less user centric and this is very, very sensitive. So here we are using IIoT to take decisions in many process industries and product industries. Suppose if anything goes wrong, so this will create a more serious problem. So we have to very careful in embedding IIoT devices and the application of analytical techniques. Okay, so we should be very, very careful in IIoT. So so now we are going to talk about few applications of IoT. So one such application is smart cities. So IoT is a key enabling technology for smart city. So nowadays, like water, electricity, air quality, people are willing to live a more sophisticated life, and they are ready to spend any amount of money to get the sophisticated life, right? So, so one such application will satisfy all the requirements of the people who want sophisticated life. So the IoT sensors are mainly embedded in smart cities. The IoT sensors are embedded in physical infrastructures such as street lights. So in street lights, no, so they embedded the sensors will automatically detect the intensity of light. So based on the light intensity, it will automatically switch on and switch off the lights. So there is no need for a human to operate the street lights. And water meters. So in IoT enabled water meters, so it will automatically measure the pressure, water level and pH level, and it also detect if there is any leakage in the water connection. It will immediately intimate to the concerned person. And similar to the traffic signals. So nowadays we are able to get the traffic information, and we are able to take decisions. We will with the help of this traffic data, we will be able to identify the next best optimal route to reach our destination, right? So these are the applications of IoT in smart cities. And so some other examples in smart cities are given here: monitoring social media for possible threats, to assess the security condition from the surveillance camera. So from the camera, we can get the input and we can analyze the data. And if there is any security related issues, we can immediately intimate to the police person. And air quality monitoring. This is one of the important applications. So this will continuously monitor the quality of air. And the lighting control system, just now we spoke, traffic monitoring, smart parking system. So suppose if you are going to the public parking system, there is no dedicated parking for your car. So the IoT enabled parking system will give you information like where you can find the empty slot, and it will direct you towards that empty slot. So with the help of blockchain, how the payment will be given and all, we will discuss it later. And then smart homes. So in homes, the IoT enabled homes, and most of the appliances are IoT enabled devices like smart TVs. You can operate air conditions. You can unlock and lock the doors. Okay, remotely you can lock and unlock the doors. You can monitor your house remotely with the help of surveillance camera input. So all those things you can do. But the only disadvantages in smart cities and smart homes, most of our personal informations will be taken and it will be fed into the cloud. So we need to think about the security related things. So how our data will be secured in cloud. Okay, so those things we will discuss in upcoming slides. And the second important application of IoT is in manufacturing. So some of the challenges that manufacturing industries are still facing are poor machine health monitoring. Okay, and the second important challenge is improper inventory management. Suppose if you take any automotive industry, it has the n number of workstations. Suppose if any workstation is, if there is any defect in one particular workstation, then the entire production will stop. So generally, in any manufacturing facility, scheduled maintenance will be done, right? And so if you take, I'll give you one example that take one automotive industry. It is started in 120 years back. Just 3 years back only they have started to implement IIoT. So still they are using the legacy systems. Okay. The thing is, we have n number of machines. all the machines are standalone machines. We are able to produce huge chunk of data, but the thing is, we are unable to retrieve the data from the machines. Okay, so there is most of the manufacturing companies are lacking in retrieving the data from the standalone machine. But data is there, but we don't have the facility to retrieve the data. So that is the one of the biggest challenge in manufacturing facility. So this the introduction of this IoT connected all phases of the industrial process. So with the help of IoT devices, now we are able to retrieve all information from the machines. You can measure the temperature, you can measure the speed, you can measure the vibration, you can measure pressure. So all parameters related to machine will be captured with the help of IoT devices now. So apart from embedding the IoT devices in machines, we can embed the IoT sensors in warehouse cells to automatically track the inventory, so which will further enhance the efficiency of the system. And with the help of big data analytics, as said earlier, we can do predictive modeling. And so with the help of IoT sensors, advanced IoT sensors, and the advanced data analytic techniques, so now we are able to prevent the defects. So now we are able to collect a huge chunk of data from with the help of IoT devices. With the help of advanced analytics, we are able to predict the defects. Okay, apart from the scheduled maintenance, now we are able to do predictive maintenance. So we are able to predict the defects. So by predicting the defects, we are able to reduce the downtime. And the second benefit is maximize the equipment performance. Okay, so because of this introduction of IoT sensor, we are able to improve the performance of any equipment. So let us take one example. So in any automotive industry, the body parts are assembled by using welding robots, right? So in welding robots, usually the tip length varies from 5 to 6 centimeters. Okay. So when the length of this welding tips reaches 0.8 centimeter, it has to be replaced. So in the legacy system, there is no facility to continuously monitor the length of the welding robots, whether it has reached 0.8 centimeter or not. So currently they have scheduled replacement. So every 1 hour they will go and they will replace the welding robots and welding tips. Whether it reaches 0.8 centimeter or not, every 1 hour they will go and they will replace it. Suppose let us have some 5 welding robots. Okay, some 5 welding robots. So at 1 hour, some welding robots may reach 1 centimeter, some welding robots may reach 1.8 centimeter, some welding robots may reach. So based on the usage rate, the length of the welding robot may decrease. Some welding tips may reach 3 centimeters. But irrespective of whether it is reaching 8 centimeter or not, the maintenance person will go and stop all the welding robots. He will replace all welding tips. So now, so look at the performance. So here we can allow this 3 centimeters. So still 3 more centimeters are there. We can allow this welding robot to work continuously for next 1 hour. But we don't have the facility when it will reach the 0.8 centimeter. So now with the introduction of this IoT devices, we are continuously able to monitor the length of the welding tips, and the system will alert when it reaches 1.8 centimeter. 1.2 centimeter. Okay. So when it reaches 1.2 centimeter, the system will alert the maintenance person. So immediately he will go and he will stop that particular robot and he will replace this particular welding tips. So now the loss due to the scheduled replacement is drastically reduced. So this is one benefit of implementing IoT in a automotive industry, and there are many more applications are there. And next is cut warranty cost. So here now we are able to embed IoT devices in all machines, right? So we are able to continuously monitor the progress of product in each and every stage. So there are in the production line there are n number of machines, and so each machine will do some activities. So at the end of the production line, you will get a end product. So with the help of IoT, now we are able to monitor the progress of product in each and every stage of a production line. So if there is any defect occurs, immediately the defective part will be replaced from the production line. So because of this, at the end of the production line, you will be getting only a good quality product. So there is no possibility of getting defective product. So because of this, we can avoid the number of warranty claims. Okay. So with the help of IoT, we can reduce the number of warranty claims. So because of this, we are able to increase the production yield, and we can reduce the maintenance cost. So whenever there is a requirement for maintenance, we will do maintenance apart from scheduled maintenance, and we will drastically reduce the downtime. So overall, this will the application of IIoT will enhance the customer experience in terms of producing a good quality product, in terms of producing increasing the productivity, and improve the efficiency of the system. So overall, this will enhance the experience of the customers. So now the next important application is it is predominantly used in transportation and logistics. Okay, so I will take this, I will explain this particular application along with blockchain, so that you will have the feel that how IIoT and blockchain is very much important in transportation and logistics, and you will also understand the use of transportation and logistics in any product supply chain. Okay, so I will skip this slide as of now. We will discuss when we discuss blockchain technology. Okay. And next important application is healthcare industry. So this because the IIoT captures data from wearables and other medical devices. So here in medical industry, it is called as Internet of Medical Things. Okay, Internet of Medical Things, and which enhances the digitization of healthcare industry. And so the main purpose of this IOMT is to monitor the exercise, sleeping pattern, and regular activities of a person, and what are the health habits he has. So based on that, it will diagnose the if he has any disease or not. The system will be able to diagnose the disease, and it will suggest you a treatment plans. What are the treatment plans that we can take? Okay, and this IoT automates the patient's workflow from the admission of the patient to the discharge of the patient. So it will completely automate the entire process. And one more application is remote temperature monitoring. This is especially for vaccines. So for vaccines, it should be maintained in a proper temperature. So with the help of this IoT devices, now we are able to monitor whether the vaccines are in proper temperature or not. Right, and air quality sensors. So in and around the hospital, how the quality of the air is there. So those kind of things you can measure, and you can one more application is medication reminder refill technology. So in ICUs, the attendant or this nurse has to frequently go and check the suppose if the patient is given a saline, then they have to frequently go and check. Suppose if we have an embedded system, so it will automatically alert the when it reaches a particular level, it will automatically alert the attendant or a nurse or doctors. Okay, so this will completely the IoT technology in healthcare industry completely automate the process. Okay, and so apart from this, it also helps to optimize the pharmaceutical manufacturing process, and which will result in low drug prices. So these are the applications of IoT in healthcare industry. And one more thing is, nowadays we have this online consultation. So during this COVID time, apart from COVID patients, the other patients were not able to go to the hospital. So in during that time, the concept of online consultation, virtual visits, all those things came into picture. But the thing is, they were unable to continuously get the data, directly get the data from the patients. So suppose if we have a system to measure the physical parameters of a patient remotely, then it will be we can have this kind of virtual visit. So through remote monitoring, we can the doctors can monitor the patients, and he can prescribe the medications. So there is no need for the patients to come to the hospital physically. Okay, and many during this COVID time, many patients got suffered. because they were not able to visit the hospitals. And the last application is retail industry. So suppose if you take any retail industry, so those industries mainly deploy a research group to analyze the performance of the consumers and what is their expectations. Suppose the retail industry wants to introduce some new product, so first they will do some kind of survey to understand the customer expectations and customer behavior. Okay, so they used to spend some amount, some money in collecting the data through survey from the consumers. So now with the help of IoT devices, the retailers captures data in store and digital channels. So through digital channels, they are able to collect the data from the consumers directly. One more thing is in retail industry, positioning of products itself is very, very important. Okay, so this is one factor which induce the customers to buy. So where to position which product is an important optimization problem in retail industry. So the application of IoT devices. Okay, the application of IoT devices. For example, if you have a inventory tracking chips, it will automatically track the inventory level of the product in each shelf, and we can have some kind of camera in each shelf, so which will continuously monitor the movement of customers in the retail shop, and so in which shelf they are spending more time, which product is fast moving. So all those informations will be collected, which will help the retail stores to introduce new product or to concentrate on which product, where to position the product, where to position the product, in which shelf we have to position the product. All those decisions he can take. And in addition to that, he can identify a new market segment. Okay, so based on the customer behavior, buying pattern, based on customer experience, with the help of analytical tools and the data, whatever he is receiving from his retail shop, he is able to identify a potential customer market, and then he can able to introduce new product in that market. And so based on the customer experience and buying pattern, he may introduce some new strategies like in the new discount technology, the discount policies to different customers. So based on the buying pattern. So so IoT plays an important role in the retail industry as well. And the last one is in energy systems also IoT is used. It helps to improve the reliability, efficiency, sustainability of electrical power. So it helps to monitor the electrical equipment, electrical power system, transmission line, and if there is any defects, it immediately sent the information to the operators, and it will be immediately resolved. So these are the applications of IoT in energy systems. So overall, these are the benefits. It improves the efficiency, gives better human productivity, reduce downtime. You can operate all appliances through remote control, and then you can increase the security, right? And you can take more smarter decisions and more informed decisions. So, and then you can increase the rate of return. So these are the overall benefits of IoTs and IIoTs. So, but still, there are some challenges present in IoT and IIoT technologies. So, the first significant challenge is interoperability. So, what is interoperability? So, now we discussed that Internet of Things connects many devices through internet, and it enables machine-to-machine communication, right? And we cannot say that the devices, all devices have same protocols or same kind of architecture. So how to connect all these different devices which has different architectures and protocols through in a common system. So we can connect all these devices which has different architectures and protocols through a specified API calls. So this is one of the challenge in IoT. And the second important challenge is cyber attacks and data theft, right? So now we are saying that through sensors, informations are collected and it is fed into the cloud storage, right? So there is a common system, and there is no guarantee that someone will go and hack the data. And in smart cities and smart homes, we are giving our personal information to the cloud. There is no security, there is no assurity that our data will be safe, right? So that is one of the biggest challenge that IoT has. And the second one is second important challenge is cyber attacks. So apart from stealing the data, some of the hackers actually attack the particular server or web service to discredit or to damage their business. Okay, so one such attack is called as distributed denial of service. Okay, so here I will explain this concept by using this picture. So here you can see this is the traffic. You can see there are the capacity of this road is two cars at any point in time. You can two cars can go in this road, and in normal traffic the traffic is smooth. Suppose if any cars intrude into this traffic, it will automatically affect the flow of this cars. Similarly, in normal activity, in normal days, the request to visit a particular web service or to visit a particular site, each web service or website has its own limitations. So limitation in terms of number of requests per second. So it will have a limit that it may take X number of requests per second. So this hackers, what they will do is, so they will have a bot. So these kind of bots are called as malicious bots. And bot is nothing but it is a program. It will do the activities instead of human. It will do the activities based on the sequence of operations written in the particular program. So there are many good bots are there. You can you might have heard this term Google bots and chat bots. Okay, so instead this will replace a human for doing some specific kind of activities. So there are some malicious bots which is actually developed by this hackers, and these bots will be embedded into the IoT system. What they will do is they will unnecessarily create some request. Okay, they will need from each and every node, it will unnecessarily create some request. So because of the number of requests exceeds the capacity limit of that web service or internet, this will discredit or damage that particular company's business. Okay, so this is one disadvantage of having this IoT. And some of the consequences because of this hackers are the response to requests will be much slower than normal. Sometimes your request may be totally ignored, or sometimes the website is responding very slowly. Sometimes it is completely unresponsive, and sometimes you are not able to access that particular website. Okay, so if you take any target website, because of this hackers activity, so these are the consequences will happen. Okay, so the thing is, we should avoid these kind of security related issues and these kind of DDoS attacks. Okay, and the other important challenge is dependency of centralized servers. So already we spoke that the data, whatever we are receiving from many physical devices, will be fed into a common cloud server, right? So, so because of this common cloud server, this will increase the maintenance cost, and one major disadvantage of having this kind of centralized server is scalability. So it has its own limitations that these many number of IoT devices can be connected to this centralized servers. So to increase the capacity, we have to spend more amount in terms of maintenance cost and infrastructure cost. And the next important challenge is vulnerable to single point failure. So in this picture, you can see there are many nodes, and the informations collected from different nodes are collected in a common server and in IoT server. The thing is, suppose all the informations are fed into this common server. If anything happens to the system, what will happen? So we cannot get the data, we cannot retrieve the data because we are depending on this centralized server. Okay, so that is an important challenge that has to be overcome in IoT applications. And so as of now, we discussed many challenges, right? So the major challenges are, first thing is security. Second thing is we should avoid hackers. Okay, we should avoid hackers, and we should not depend on single point. Okay, we should not depend on single point. So instead of having the entire data in a common system, is it possible to have the data or duplicates of the data in different systems, so that if there is any problem occurs in a centralized data, we can able to retrieve the data. So we need a technology to overcome all these challenges faced by IoT and IIoT technology. And so one such technology is a blockchain technology. So this is the best way to secure the Internet of Things. So we cannot overcome all the challenges faced by IoT. So we can overcome the challenge or resolve the challenges in terms of data security, in terms of scalability, and in terms of duplicating the data with different devices. Okay. And one more thing is we can completely avoid the hackers attack. No one can enter and no one can steal the data, and no one can change the data, no one can attack the server. Okay, so these are the main advantage that we can have by using the blockchain technology. And so many of us have most of the people are saying that Bitcoin and blockchain are same, but both are not same. Bitcoin is a cryptocurrency which was introduced to resolve various issues currently the banking system is having. And the blockchain is a technology which enables the Bitcoin transaction. So Bitcoin is a cryptocurrency which was introduced. The concept was introduced by a person called so it was introduced by a person called Nakashimoto in 2009. Okay, and it resolves various issues in the current banking system. So first, let us see what are the challenges that the current banking system has. Okay, there should be some disadvantages in the current banking system. That is why they have come up with the concept of cryptocurrency. It is a digital currency. The first challenge is transaction fees. Suppose if you want to transfer money from your account to your friend account. Suppose if you want to send some 10,000 rupees, and at the receiver's end, they cannot get the 10,000 rupees. There may be some transaction amount. It will be deduced from the amount transferred by you. Okay, so in current banking system, we have a huge transaction fee. And in current banking system, have private ledger. So you have your account in your bank. So you don't have the permission to access your ledger. You don't have the permission to see your transaction. And whatever transaction you are doing with your friends or some persons, it has to pass through a centralized ownership. So through a centralized body, you can transfer money. You cannot directly transfer money from your account to some other person's account. Okay, so that is one issues with current banking system. That is, you don't have the facility to access your private ledger, and you don't know whatever money you have invested in a bank is utilized for what purpose. So for which persons they have given your money as a loan. So you don't have any information about your money. You have just have an account in that bank. Whenever you are depositing or taking money from the bank, borrowing money from the bank, those time only you will come to know that what is your transaction happen in your account. The rest of the time you don't have the access to get the information how your money will be utilized. And the third issue is double spending. For example, suppose if I have 10,000 rupees in my account. 10,000 rupees in my account. Okay, right? It is a kind of giving check to different people. So I have only 10,000 rupees, but I can give n number of checks to different persons. I can give check to person A for 10,000 rupees. I can give 10,000 rupees for person B. Like that, I can give any number of checks. And at the same time, also I can do online transaction to more than one person. But the thing is, I have only 10,000 rupees, but I can do n number of transactions. But this will give. So this will give the bankers to identify which transaction is the valid transaction. Okay, so this kind of transaction is double spending transaction. So with this money, we can do n number of transactions. Okay, so the bankers will confuse that which transaction is the valid transaction. And the fourth one is financial depression and no transparency. So this is one of the important problem in current banking system. So a few days back, you have heard of the Punjab National Bank went to financial depression. So what is the reason for that? It is unnecessary. It is giving money as a loan to a business person with 14,000 crores or 15,000 crores, and those persons will not be able to return back to the money. Okay, so suppose if you take any common person, if you want to apply for a housing loan or if you want to apply for a educational loan, the bank people will ask you so many documents. So we have to produce so many documents, and we don't know whether our loan will be approved or not. But because there is no transparency in the current banking system, that is why we are facing this kind of financial depression. Okay, so for some banks, let us take one X bank. It is giving some 15,000 crores to a business person, and he left out this country, right? So without taking a proper document, how the bank can give these huge quantity of money to that particular person? So there is no transparency in the existing bank system. So how your money is spent, you don't have any idea that how your money is spent. Okay, in which how it is invested in some other applications or not, you don't have any other information, right? So this is one of the important challenge in current banking system. And then bank fraudulent. Okay, so this is in your practical experience, you might have faced these kind of bank fraudulent. Somebody will call you and they will ask you OTP. Your account will be credited these many amounts. Kind of phone calls you will get, and at the end of the day, if you see your account, your money will be debited. So all kind of bank fraudulent will happen in the current banking system. And these issues are generally resolved by bitcoins. So it is a cryptocurrency, and whoever is having Bitcoin will be connected to a Bitcoin network, and whatever transaction happens in the Bitcoin network will be disclosed to all stakeholders in the blockchain. Okay, so blockchain is a technology which enables the transaction of a Bitcoin. So let us take a blockchain Bitcoin network. So these are the nodes or persons who have Bitcoins. Okay, so they will be connected to all nodes. All nodes are connected to all other nodes. Okay, all nodes are connected to all other nodes. So whatever transaction happens in any node will be informed to all other nodes. Okay, and the transactions will be valid by all entities in that, all stakeholders in that network. So no one can cheat others, right? And there is no centralized power. So in case of current banking system, you can transfer your own money to your friend through RBI. But in case of in case of cryptocurrency or Bitcoin, you can directly send your Bitcoin or cryptocurrency to your friend or the stakeholders of your Bitcoin network. So there is no intermediaries in Bitcoin network, and no private ledger. As I said earlier, all transactions happen in that particular network will be shared across all the members in the Bitcoin blockchain and prone to hacks. So this I will explain with one example. So no one can go and hack the data, or no one can go and change the transaction details. For example, in case of current banking system, suppose if I gave money to my friend to 10,000 rupees. Suppose if that friend returned back to money to me, return back the same 10,000 rupees to me. But in my ledger, instead of 10,000, I may write 9,000 rupees. Okay, so we can do any kind of malpractice in current banking system. But in case of Bitcoin or cryptocurrency transaction, we cannot do any cheating, right? And there is no double spending. Since whatever transaction you are doing in your from your node, that should be approved by all other stakeholders in the Bitcoin network. So if you have a valid transaction, then only the transaction will be approved. Otherwise, it will be rejected. So these are the benefits of having cryptocurrencies, and all these transactions, all these Bitcoin transactions are done through blockchain technology. So now we will see what is blockchain technology. And one more thing is, this blockchain technology is not only used for Bitcoin transaction. So nowadays it is used for all other purpose. You can use it in healthcare industry. You can use it in food supply chain. You can use it in manufacturing industry. You can use it in logistics and supply chain. So in all industries, you can use blockchain, irrespective of whether it is a Bitcoin transaction or cryptocurrencies. You can use this technology in all domains. So now we will see what is blockchain, right? So blockchain. So the definition for blockchain is it is a distributed, decentralized, immutable, encrypted public ledger. Okay, it is a distributed, decentralized, immutable, and encrypted public ledger. So this is the definition for blockchain. So in this picture, you can see the various features. Various features or characteristics of a blockchain. So it is a distributed system. Okay, it is a distributed system means, as I said earlier, so this is a distributed system. Okay, suppose this is a system. So this is this rectangular box are nodes. Okay, so this is a system. Here also you can have a system like this. Okay, you can have n number of systems. All systems are connected to all other nodes. So whatever transactions, it need not be a money transaction. It could be any transaction. It could be a inventory transaction or some other transaction. Okay. It will be shared across all the, so the duplicate of the transaction details, the duplicates of the transaction details will be available to all nodes. Okay, so this is called as distributed network. Okay, all participants, all network participants will have the full copy of the ledger. For example, suppose so Bitcoin started in the concept of Bitcoin started in 2009, right? So from there itself, the blockchain has started. The first block of the blockchain. So blockchain is nothing but it is a chain of blocks, right? So the first block is called as Genesis block. Okay, so from there you can have n number of blocks. Okay, suppose today if you want to join in this Bitcoin network, Bitcoin blockchain network, all the transactions from this Genesis block, first Genesis block, you will be able to get it in your system. Actually, it started in 2009 itself. But today, if you want to join in the Bitcoin network, you are able to get the transaction details from the starting of that particular blockchain network. So many people have many blockchain networks. Okay. So you can get the complete transaction. You means not only you, all entities or all stakeholders in the network will have the complete ledger of all transactions. And it is full transparency. You can so complete. You can get the all details from the starting of the block 0. Okay, you can. But today only you have joined in this network. But you are able to get the information from block 0. Okay, that is a distributed network. And anonymous. Anonymous means in a blockchain network there could be n number of participants or stakeholders, and you will be able to know the transaction of all persons. Okay, you will be able to know the transaction of all persons. But the name is, you cannot find the exact name. Okay, I will show you. Just. So here, sorry. Yeah. So here, so this is in this website you can see the transaction of Ether blockchain. Okay, Ether blockchain is another kind of blockchain, which is not only used for cryptocurrency transaction. This can be used for any general purpose. It can be used for you can create your own smart contracts for manufacturing industries or healthcare industries. So you can develop your own applications. Okay, so this is a general purpose blockchain. So here you can see here you can see the latest transaction happens in this day. Okay, so here you can see from this number, from some hexadecimal number you can see so this is an account number, this is an account details or of from people, and this is a 2%. Okay, and the amount that has been sent from this person to this person, and the timestamp at what time the transaction happened. All these informations will be given. And so here you can see some numbers, but you don't know who is that person, right? So this is called as anonymous. Okay, this is called, so you don't know the identity of the participation, but the thing is you are able to see the transaction of all entities, all stakeholders in the blockchain network. Okay, so here you can see the list of transactions happens today, and you can see the list of blocks created. So we will discuss now in detail. So this is called anonymous. You can see the complete transaction, but you don't know the identity of each person. And timestamp. So whenever there is a transaction, and if the transaction is a valid, okay, so here you should note down this point. If the transaction is valid, then only you can add this transaction to the block. Okay, so a block is an entity in the blockchain. It has n number of transactions. So the whatever activities you are performing in blockchain, along with the timestamp, you will have the record. Okay, and unanimous means whenever you are doing a transaction, so it should get approval from all other entities in the blockchain. So that was I discussed here. Whenever, suppose if you want to send, let us take this is person A and this is person B. If he wants to send money from A to B, he can send a request. He can send a request in terms of I'm going to transfer money from my account to account B, right? And if the transaction is a valid, for example, in my account I have 10,000 rupees. Okay, I can transfer less than or equal to 10,000 rupees. I cannot send 15,000 rupees to B. Okay, suppose if I send, I have in my account I have 10,000 rupees, but if I send a request to send 15,000 rupees to B, this is an invalid transaction. So this invalid transaction will be immediately identify all other stakeholders, and it will be rejected. Okay. So that is called anonymous. All participants in the network do validation about your transaction. So once your transaction is valid, then only it will be added into the block. Next one is immutable. So whatever you are doing, whatever transaction you are doing, you can append the data into the blockchain. So blockchain, so it is a sequence of blocks. Each block has a list of transactions. Okay. And you can append the data, you can append the transaction into the block. You cannot go on modify the existing transactions. Okay, you cannot change anything into the existing transactions. And all data are encrypted. Okay, so here so in this so here you can see this is the encrypted data. So you don't know who is what is the name of the from people, what is the name of the two people, and what. So here you can see this is the transaction information. This is also in hash code. So it is completely encrypted. You cannot go and hack the system. You cannot go and hack the information. So to retrieve the information, you have to solve the puzzle. Okay, it means that you have to give exact input which is equivalent to this particular hexadecimal code. Otherwise, you cannot retrieve the information from the block. For example, it is it is a kind of a number lock. For example, if you have a number lock and you will have some number combination, right? Suppose if you have a number lock with 4 digits, so how many number of combinations of keys that you can generate? As a person, it is a private data. It is a private key that you should know. Otherwise, somebody will go and hack your system. And suppose if you take 4-digit data, and so in this case, 4 single-digit data means in this case you have to create 2 power 4 different combination of numbers, and you have to identify the exact number to open your system. Okay, so it takes too much of time to retrieve the data. So your encrypted data is like this. So you have to give exactly the same input, which will create the same hash code. Okay, so for that you need a mathematical skills and computational skill to solve the problem. So that we will discuss right now. And the next feature is programmable. So here programmable means for a Bitcoin blockchain, we will not have this kind of smart contract. But other blockchain frameworks, we will have smart contracts. So you can have a certain set of rules, and those rules will be approved by all other stakeholders in the system. And in the set of rules, you can automate your business process, and whatever you want to do, whatever you want to implement in your system, you can do. And the rules are defined and it is approved by all stakeholders in your system. No one can go and change the system. And this program is written in the blockchain. So this is called smart contract. So this we will discuss in the upcoming slide. So this is an example. So here you can see a block. The blockchain is the collection of all recent transactions that have happened and verified. Okay, all verified and validated transactions will be appended into your blockchain. And it is a sequence of cryptographic hash linked blocks. Cryptographic hash linked blocks means all information will be converted into a hash code, right? And it is, you cannot do any reverse engineering. You have to solve a complex mathematical puzzle to find out the exact input. If you give that input, the hash algorithm should give the exact hash code of this this particular hash code. Okay. And each block has three types of information. One is the current hash code of this block, and the previous block's hash code, and data. Okay. The hash code is created based on these three information. And one more information is called nonce information that I will discuss. So if you look at this picture, you can have a list of blocks. So in each block, you will have a number that will be encrypted by using hashing algorithm. And in each block, you can see list of transactions. In transaction, you will have the transaction information. So from which stakeholder to which stakeholder, what information is transferred. And the timestamp will also be attached in each transaction. So here, each block has its own memory capacity. Let us take, suppose the block has 80 MB of capacity. Once the list of transactions added into this block reaches 80 megabytes, then that particular block will be added to the existing block after getting verification from all other stakeholders in the blockchain network. Then new block will be created, and each block is linked with the previous block hash. So, so in this case, I said no. So from the starting of the block, you will be able to get the all blocks. So with the help of previous hash block, you will be able to trace all transactions. Okay, all transactions happen in a particular block. Okay. So now I said that all transactions, whatever the information you want to transfer, it could be a money or it could be some information, it will be converted into encrypted hash code, right? And so this algorithm is called as hashing algorithm. So in blockchain, actually, this SHA 256 hash algorithm is used. Actually, actually, this converts the transaction into a hexadecimal numbers with the fixed length of 64 bits. Irrespective of the number of characters in the transaction detail, it will convert the entire transaction detail into a 64 bits of hexadecimal numbers. So hexadecimal number varies from 0 to 9 and A to F. Okay, so if you look at the hash code, it is a combination of numbers from 0 to 9 and A to F. And if you look at the hash code of each transaction or each transaction, so this is the transaction details, this is the from address and to address. All information will be converted into a fixed length of hash code. That is 64 length is the fixed length for the hash code. And this is SHA 256 algorithm do this activity, which converts the transaction information into a 64 fixed bit length, which is a hexadecimal code. And this is called as secure. So SHA 256 is secure hash algorithm. Okay. So as I said earlier, you cannot do reverse engineering. You need a special skill to retrieve the information from the hash code. So you will be given as a part of the blockchain network, you will be given a encrypted data. So it is a hash code, it is encrypted data, and to get the encrypted data, to retrieve the information from the encrypted data, you have to solve a complex mathematical puzzle. You have to find out the exact input which is exactly matched to this hash code. Okay, so I will show you one example. So here you can see how this SHA-256 algorithm works. So this is an empty block. Okay, this is an empty, there is no data in this particular box. So for that, the hash code, if you look at the hash code, if you count the hash code, it is of 64-bit length. You can see it is a combination of numbers from 0 to 9 and A to F. Okay, suppose if I add here, you cannot track the changes in this hash code. Just I'm adding A. You know that I think you just I'll see, just look at here in the first digit E3, B0, C4 and B855. Suppose just I enter A, completely it changes. Okay, C8 starts with CA97. So instead of small a, if I put capital A, it will give some other combination of number. So instead of A, if I put simply dot, if I put dot is a character. If you modify anything, it will automatically change the hash code. And it is very, very difficult to track the changes in this hash code. So that is why you have to give the exact input. For that input, the hash code should be equal to this corresponding hash code. Then only you will be able to retract the data from the existing distributed network. Otherwise, you cannot extract the data. That is why we are saying that blockchain network is safe. So nobody can go and hack it. Nobody can go and change the data in blockchain. Okay. And so suppose if I put my name Kalpana in capital letter, you can get some name. The same. If I get small letters, you can get some other name. So now I hope you understand how the hash algorithm works and how the information is converted into hash code and how it is difficult to re-engineering the data, right? It is difficult to retrieve the data from this hash code, right? So because of this complexity, no one go and hack your data, right? So now I hope you understand how this SHK-256 hash algorithm works. Yeah. So now we will come to this. So with the help of this SHA-256 algorithm, the transaction data will be converted into hash code. And one more thing is, irrespective of number of characters, you can get the same fixed length. So if I put A, also you will get 64 length. If I give some other text, also you will get 64 numbers. So this is the standard protocol followed in a blockchain network. Okay. So whatever may be the number of characters in the data, you will get a fixed length of hexadecimal numbers. Okay. All right. And as I said earlier, you need a special skill to retrieve the input. So you have to find out the exact information corresponding to the hash code. Otherwise, it is very, very difficult to get the information from the hash code. And in blockchain network, I said earlier, right? So this is a blockchain network. Anyone who want to participate in the blockchain network can be a miner. So there is a special entity called miners. Okay, miners. So here, suppose if you want to join in the blockchain network and you have the special skill to solve a mathematical puzzle, or you are able to write a complex algorithm to solve a mathematical puzzle, then you can act as a stakeholder as well as a miner. So here the role of the miners are they use their skills to solve the complex mathematical puzzle. For that, they have to spend a lot of resources. So here one person can be a miner or a group of persons can be a miner. So here the main role of miner is they will solve the mathematical puzzle, or they will find out the exact input for corresponding to the hash code, and they will get the corresponding data, and they are the person who has the right to add the valid transaction into the blockchain. Okay. So whatever transaction you are sharing across your network, that is validated by a group of miners. You can have n number of miners. All persons who are the stakeholders of the blockchain can be a miners, or few persons who has the special skills to solve the mathematical puzzles or can be a miners. And these are the persons who approve the transaction. So who validate the transaction, who verify the transaction, and who has the right to add the transaction, valid and verify the transaction to the existing blockchain network. So for mining this mathematical puzzles or to solve that mathematical puzzle, they have to invest lot of resources, computational resources to solve the problem. So for that, whenever a transaction is broadcasted across the blockchain network, all miners will compete to solve the mathematical puzzle. The miner who first solve the puzzle will get the credit. Okay, and once he solved the puzzle, he will attach the proof. He will attach the solution along with the transaction. That is called proof of work. Okay, suppose if you have n number of miners in a blockchain network, so he is a miner, he is a miner, and he is a miner, and some persons or just a blockchain stakeholders. Okay, any transaction happened in this blockchain network will be approved by this miners. So whenever there is a transaction, the transaction will be given to all the miners. All miners will compete each other and they will try to solve the complex mathematical puzzle because they want to try to extract the account details of that particular person. Okay, so the miner which solved the problem first, he will attach the proof. Once he validates that the transaction is valid, and he will attach the proof of work or the solution of the mathematical puzzle along with the transaction. All other miners in the blockchain network will validate the proof of work. So once getting validated or once getting approval from all miners, the particular verified transaction will be added into the blockchain. Okay, so this is the valid and verified transaction. So this is done by the validation and verification is done by miners. Okay, who mines the puzzles or who solves the mathematical puzzles. Solving mathematical puzzle means to find out the exact input for this corresponding hash. Okay, I will show you one example. So here, yeah. So this is the first block. This is actually this block is for demo purpose to understand how the blockchain works and how the hash code works. So here you can see the block number. There is one number called nonce number. So this is a standard protocol of any blockchain technology. And here you can send the transaction data. Okay, you can set the transaction data. And this hash code. So this hash code is the hash code, encrypted code of this particular transaction in this data block. Okay, for example, here I am going to give a transaction detail like so here you can see one more protocol in Bitcoin blockchain is the first 4 digits should be a zeros. Okay, so if you do any modification, it will the first 4 digits will be changed. The thing is, you have to find out the corresponding nonce number, which will convert the first 4 digits into zeros. So that is the work of miner here. He will find out the combination of numbers that will convert the first 4 digits of this hash code into zeros. Okay, so before that it is a valid block. Before that it is a valid block. That is why you can see the green color. You can see the first 4 letters. It is a zeros. If I change anything in this data space, but it will change the color of this block. That means that you have to identify the corresponding combination of nonce number, which will change the first 4 digits to 0. And this hash is a combination of block number, nonce number, and the data whatever you are having here. Okay, suppose if I click mine here, it will take some time. Okay, and you can see the first 4 digits become 0 here. So now you could observe that there is a change in nonce number. Once again I'll do it. That if there is no suppose if I take there is no digits and just copy, take this number 72608. If I change it to just 1, and it will change it to some other hash code number. If I mine it, now see, this number will get changed. Oh, okay. So the role of the miner is he has to identify the appropriate nonce number here, which will give us a hash code with first 4 digits at 0. Okay. And so whatever transaction, so it should be validated and it should be get approval from everyone. And so there is a difference between encryption and decryption. Encryption and hashing. In case of encryption, you can do decrypt, but in case of hashing algorithm, you cannot do reverse engineering. And one more thing is, in case of blockchain, I said earlier, you can traverse through all blocks to get the transaction of any data through this previous hash code. Suppose if I want to change anything in the code, so one of the main feature of blockchain is nobody can go and change the existing blocks, or nobody can go and change the existing transaction. Suppose if I do any changes in any of the blockchain, any of the blocks in the blockchain, so that will immediately throw an error, and it will be reflected to all other stakeholders in the blockchain, and so no one can do any changes. Okay, so for that I will show you this example here. I think I'm taking too much time. So here you can see this is a blockchain. This is a blockchain for demo purpose. Here in this blockchain there are 5 blocks. Okay, there are 5 blocks. So each block has the information of block ID, nonce number, and the previous hash, and the hash of the corresponding block. Okay, so this hash of the corresponding block is a combination of block number, nonce number, and whatever the data here, whatever we are having. So all green color indicates that it is a perfect block. Suppose if I want to change anything in this block, immediately you can see there is a red color signal. You cannot go and change anything. So immediately it will change the hash code. Okay, then you have to find out the mining, you have to find out the appropriate nonce number to validate that particular block. You cannot do any modification in that block. For example, in between, suppose if I am going to change anything, here I am going to type all other blocks from this block will be indicated as in red color. It indicates that there is some changes are happening in the block. So immediately it will be reflected to all stakeholders in that. Then the thing is, you have to mine each and every block. So this will take a lot of time, and no one appreciate this kind of changes in the block. So that is why we are saying that in blockchain, you cannot do any modification without the approval from the miners, and no modification is allowed. You can do addition of data. You can do addition of valid data. That is the important feature in blockchain. And here you can see how the blockchain works. Suppose, shall I take 10 more minutes, 10 or 20 more minutes to complete this? Hello?
Yes, madam.
So here, sir?
Yes, madam. Tell me, madam.
Shall I take some more minutes, because I'm
take, madam, another 10-15 minutes, no problem, madam.
I'm going out of time, I think, running out of time.
Yes, no problem, please.
So I will complete this blockchain.
Yes, madam. Please go ahead, madam. Please go ahead, madam.
So here you can see how the blockchain works. A simple transaction we will take. Suppose if you want to transfer money from one entity to another entity, one of your friend from A to B, let us take 2 entities in the blockchain. If you want to transfer money from A to B, the transaction details will be given to the blockchain network as a hash code. So whatever we just so before this slide we saw in the website in the demo, right? Whatever transaction will be converted with the help of SHA algorithm, the transaction details will be converted into hash algorithm, and this hash code with the help of SHA 256 algorithm, and that hash code is broadcast across all the miners. Okay, broadcast across all the miners, but all the members in the blockchain will be able to see all transaction details. Okay, but they are able to see the verified and valid transaction details, but the new request will be sent across all the miners. Okay, these miners will compete each other and try to find out whether it is a valid transaction or not. Okay, the person who is completing first and who is able to find out the exact input corresponding to the hash code, he will be the winner, and he will attach the proof of work along with the transaction. And the proof of work is proof of work. The transaction details along with the proof of work will again transferred across all the miners. So here all the miners will verify this proof of work and the transaction. Okay, so once all the miners give consensus about this proof of work, then that will be considered as the valid transaction, and the valid transaction will be added into a block. Okay, so once the block reaches the maximum capacity, it will be added into a blockchain. So for each transaction, for each valid transaction, to add a valid transaction in the blockchain, each miner is getting around $0.2. Okay. So in a minute, approximately eight number of transactions happen in blockchain. In Bitcoin blockchain is some around 8 to 10 transactions. And the miner who is able to add a block into the existing block will get 12.5 Bitcoins. Okay, so there is it has its own dollar values. Daily the dollar values of Bitcoin changes. So for adding the new block into the existing block, the corresponding miner will get a reward of 12.5 Bitcoins. For that, he has to spend a lot of energy in terms of computational power to identify the corresponding input for the hash code. Okay, so this is how this blockchain works. And so these are the technologies in blockchain. One is private key cryptography. So there are two types of keys in blockchain. One is public key and the other one is the private key. Public key is nothing but it is like your Gmail account ID. Okay, suppose if you want to try and send any message to your friend, you need the mail ID of that person, right? But you need not require the password of your friend, right? So here public key is like your Gmail ID and private key is like your password, right? And this private key should be you have to keep it confidential. You should not disclose the private key to anyone. And to secure the identities of the blockchain network, the key is encrypted with the help of hash algorithm, so that you can see the transaction, but you cannot see the actual details of the transaction. Okay, but suppose if you want to trace some transaction, then with the help of miners, you can get the transaction details. And it has a P2P network. It is nothing but peer-to-peer network. Okay, this is called as peer-to-peer network. So here you can see there are 4 persons. So here you can see the transactions happen between all these persons as given here. In case of centralized network, you will have common database, but in case of blockchain, you have a distributed ledger. Okay, all persons has the transactions of all transaction details of all other persons. Okay, suppose if any system got failure, he can later retrieve data from some other person. Okay. So there is no single point dependency. You can retrieve data from any other system at any point in time. And one of the important concept in other blockchain applications is smart contract. So this smart contract is not applicable to Bitcoin blockchain. And there are different types of Bitcoins. Public Bitcoin. So in this, all participants anyone can join in the public blockchain. Suppose if you want to buy a Bitcoin, you can join. Okay, and you can see the transaction. And if you have a computational power, if you have a skills to solve a complex mathematical puzzle, you can act as a stakeholder of the blockchain network, as well as you can act as a miner. Okay, and you can get money for each transaction for doing each valid transaction. And the second kind of blockchain is private blockchain, and it is restricted to a particular group of people in that particular organization. And within that organization, you can share the data across different departments in your organization. And based on the privilege, the data can be viewed or modified or added into the blockchain network. So this is completely restricted to a particular organization. This is private network. And this kind of private blockchain is generally developed using Hyperledger Fabric. And consortium blockchain. So it is a kind of blockchain where a group of similar organizations can form a net blockchain network. For example, a group of banks can join together and they can develop their own blockchain network. One such example is multi-chain. And the last one is permissioned. Permissioned is nothing. It is a mix of public and private blockchains. There are 650 numbers of cryptocurrency blockchains are there, and there are so many blockchain frameworks are there. Some of the examples are Bitcoin blockchain as well as Ethereum blockchain, and this is for use for all other domains. Instead of not only used for Bitcoin, here instead of Bitcoin, here in Ethereum blockchain they are using Ether cryptocurrency. Okay, so apart from digital currency transaction, we can develop our own applications by using Ethereum blockchain, and many more applications are there with the help of. So here we cannot use blockchain alone. So along with the IoT, we can use blockchain. Some of the examples are, but in some cases we can use blockchain alone. But in some cases we can use along with IoT. We can use blockchain. Some use cases are given here. Banking, healthcare, law enforcement, real estate. So in many cities, you can say double documentation. So for one land, you could find many people who are claiming for the ownership of the particular land. Okay, so if the documents are put it in the blockchain, no one can cheat others. Okay, similarly, voting system. Probably by next election, we can have this kind of blockchain related voting. So individual person's identity will be authenticated for voting, so no one can do fraudulent in voting. So if we implement blockchain into voting system, and so all the challenges, some of the challenges in terms of security, in terms of hacking, in terms of dependency of centralized server, all these challenges will be overcome by blockchain technology. So those things are listed here. And as I said earlier, smart contract is nothing but it is a computer program written on blockchain. It has a set of rules, and the rules are obligations or any protocols that that particular organization want to implement. They will have their own list of rules and regulations, and those rules will be agreed by all other members in the blockchain. So this is written in blockchain, and you cannot go and modify the smart contract, and it is completely immutable. And this will predominantly used for automating the process and and monitoring the process. Okay, and limitations of the blockchain. So here complexity. So here, suppose if you want to become a miner, then you should have a special skill, and you should have a special skill to write an algorithm to solve a complex mathematical puzzle. But you, as a stakeholder, you can join the blockchain. And the transaction cost. So here, in the current banking system also, we have a transaction cost. In blockchain also, we have a transaction cost, because for miners, they are spending so much of energy to retrieve the information by solving the mathematical puzzle to get the info from the hash code. So for that, from the network, from the Bitcoin, from the blockchain network, for each valid transaction, $0.2 will be given to the miners. And one more limitation is each block has 80 bytes of data. So once it reaches the 80 bytes, then a new block will be created. And network speed. So here we are saying that all information will be shared across all entities in the blockchain. So obviously it will affect the speed of the network. And human error. So as we said in the blockchain, one of the characteristics of blockchain is it is completely immutable. No one can go and change the things. Suppose by mistake, if you do any mistake, anything wrong into the system database, if you enter anything wrong, then you cannot go and change it. Okay, so human error cannot be resolved by using in blockchain. Once you enter means you cannot go and modify it. And then unavoidable security flaw. So here the thing is, I said if there is a valid transaction and if a miner is able to solve the proof of work, it has to be approved by all miners in the particular network. Let us take there are some 10 miners in that particular network. At least 6 miners has to approve the verified. Suppose let us have 10 miners. let us take minor 2. Minor 2 identified the proof of work. So this proof of work has to be verified by at least six minors in that particular network. Okay. Suppose if 4 members are verified, 4 members are agreeing this proof of work and 6 members are not agreeing this proof of work, means that transaction becomes an invalid transaction and it will not be added into the blockchain. Okay, so this is called 51% attack. Sometimes one minor can act as a multiple minors with different names. There is a possibility that these kind of 51% attack, they themselves talk to each other and purposely they will not agree the particular verification, approve this particular proof of work. So this is the one limitation of the blockchain, but this is the rare case. And less public awareness. So common people won't easily able to understand the concept behind this blockchain. And the one more major limitation of the blockchain is trust. Suppose, the main thing is my complete transaction is distributed across all the members in the blockchain. Okay, so here as an individual person, I can think that why should I share my information to others? Okay, so here the lack of trust, will they steal my data? And the trust among the people is there is a lack in trust among the people. So that is one limitation of a blockchain. But at least we have to believe at some extent to other persons in the blockchain. Some of the applications, and so I will complete this presentation with this last example. I have many more examples. So since I am running out of time, I'm stopping here itself. So this is predominantly the IoT with blockchain is predominantly used in supply chain and logistics. So supply chain, first let us discuss what is supply chain. So if you take any product, it crosses multiple stages from suppliers to manufacturers to distributors, retailers, and end customers. Okay, so here from suppliers to end customers, you can see the flow of products. From end customers to suppliers, you can see the flow of information in terms of demand information, right? And from suppliers to end customers also, you can see a flow of information about the product details. And money flows from end customer to suppliers. So this is a very simple supply chain. This is a very simple supply chain. If you take any automotive supply chain, let us look at here. So here, if you want to produce a car, you need at least 10,000 parts. And in 10,000 parts, nearly 3,000 parts you are getting from foreign suppliers, right? So here I have listed down only 5 suppliers, 5 different suppliers. These suppliers who are in direct contact with the manufacturing facility is called as first tier suppliers, and they have their own suppliers, right? So these suppliers are called as tier 2 suppliers, and these suppliers are called as tier 3 suppliers. So look at here. So here I have taken only 5 different components and look at the complexity of the supply chain. So here whatever I have given is a very, very simple supply chain. So this is the actual supply chain. Now think about 3,000 suppliers. 3,000 suppliers or suppliers for 10,000 parts. So just look at the complexity of the supply chain. How much, just think about the quantity of information flow in terms of demand and money flow and the product detail flow happens across different entities across the supply chain. And you cannot directly get the items directly from this supplier to manufacturing facility. You have to cross n number of legs. You have to cross n number of entities to reach the item to the manufacturing facility. For example, if you take a supplier, foreign supplier, he cannot directly send the item to the manufacturing facility. The items will be directly sent to lead logistic providers. They are the third party logistics who can combine the items from many other suppliers. And after that, it will go to the origin customs. So this will happen. This will the customs clearance will happen in the port, and then you will have a ocean carrier. You have to change the items. So from supplier to here, you have to do all consolidation of containers, and again you have to do all custom clearance, and you have to unload and load the items. And in the ship carriers, the items will be transferred, and after that, it will reach us the destination customs. From the destination customs, the items, the parts will go to lead logistics providers of this particular country. And from there, you can go to the items will go to the particular manufacturing industry. So the item crosses different entities to reach the manufacturing facility. So anything may happen in between this. Okay, so any quantity related issues or quality related, somebody can steal the items, or somebody can defect the items during loading and unloading happens in lead logistic providers. Any defects may happen. Okay, so so the IoT with blockchain will help to trace the item from supplier to this manufacturing facility. It will exactly find out where this particular defect happens in terms of quantity theft or in terms of quality defect. Somebody can go and change the unit loads and they can replace with some counterfeit items. Okay, so all these things can be traced with the help of IoT and blockchain. You can have the complete visibility with the help of IoT. You can track the items from the suppliers till your manufacturing facility, right? So this is one of the advantage of implementing IoT with blockchain in automotive industry. And the second thing is supplier visibility. So here, because of this COVID, many of the not only automotive industry, many of the industries are facing this kind of visibility. So just I will give you one example. In last 2020 January, this particular automotive industry till January, they don't have any problem of supply of goods. So they have their headlight and window suppliers in Pune, and they are continuously receiving the items from Pune till January 2020. So during 2020, February, March, the incoming of parts for headlights and windows completely stopped. That point in time only, this automotive industry came to know that their tier 2 suppliers are in China. So during 2020 January, there was a lockdown, right, in China. So during that time only, they came to know that the suppliers of the glass suppliers, the raw material suppliers of this particular glass suppliers are located in China, and they were unable to send the raw materials to this particular glass suppliers. That is why they were unable to get the items from this company. So there is no visibility about their tier 2 and tier 3 suppliers. Now there is a need to find out the dependency of suppliers, dependency of other suppliers located in across the globe, so that they can identify if any unprecedented event happens. This particular manufacturing industry may take some other alternative decisions proactively to avoid the production loss. So this is one of the need for all industries with the help of that could be addressed by blockchain and IoT network. So I'll stop my presentation here. Some more examples are there. So now the role of data analytics is, so with the help of IoT, you can collect a huge chunks of data. So with you can have different data analytic techniques: descriptive, diagnostic, predictive, prescriptive data analytics, streaming analytics. So with the help of a GPS system, you can continuously track the containers across the in ocean. So you can continuously get the streamlined input. So with the help of streaming analytics, you can identify the estimated arrival time of a customer into a manufacturing facility. And whenever you are using location related detail like GPS location, you can use spatial analytics. So this plays an important role in IoT. You cannot separate data analytics from IoT. So this is the future of IoT. So it is expected that this IoT market is expected to grow $771 billion by 2026. So many of the slowly now actually industry 4.0 was introduced in the year 2011, and slowly many industries started to implement industry 4.0, but we cannot say that all industries have implemented industry 4.0. But now people are talking about industry 5.4. So again the human intelligence, they are trying to bring back human intelligence into industry 4.4 to come up with the industry 5.0. So the technologies like IoT, blockchain, and analytics will definitely transform the industries for a better world. So with this, I will stop the presentation. If you have any doubts,
Yeah. Thank you, ma'am. Thank you for your wonderful speech. My gratitude goes up to you, ma'am, for your fantastic lecture. And here is the our session with the question and answer is now underway. And here's a question from VD Babu, which is about what is AIoT, how AIoT is different from IIoT, what is the disadvantage of Industry 5.0?
So So Industry 5.0 is in the conceptual level. So we haven't implemented Industry 5.0. So now we are slowly bringing back the human intelligence. We are going to assist Industry 4.0 along with the human intelligence. Like we can bring the collaborative robots into Industry 4.0 to come up with Industry 5.0. So we haven't yet reached the saturation point of Industry 4.0. So this is in
Thank you.
conceptual level.
Thank you, ma'am. And there is another question like any certification or PG diploma courses on IoT and blockchain technologies.
So yeah, you can find a number of certification courses in edX or Coursera. So in blockchain, so there is a Hyperledger, Unix-based system. Sorry, Unix-based Hyperledger Fabric. They are offering Hyperledger. They are offering certified blockchain courses. So you can enroll that course. That is a completely online course.
Okay, ma'am. Thank you. There is one more last question from Avani Verma. Ma'am, how do we as individuals ensure security in our IoT devices?
Ensure security.
In our IoT devices.
Yeah. So that is why the role of blockchain came into picture. So in IoT, the main disadvantage is there is no surety that our data will be secured. So that is the point I mentioned in the challenges in IoT. So, but the features of blockchain, what are the features I mentioned? So it is very, very difficult to hack the data from the IoT, which is enabled with blockchain. So whatever data, if you put the data in blockchain, nobody will go and hack the data. Your data is completely secure in blockchain.
Okay,
Because
ma'am.
the data is completely converted into hash, right? So no one can, if they want to hack, they can get the hash code alone, but they cannot retrieve the actual information.
Okay, ma'am. Thank you for your answers. And as we are running out of time, here we are going to end our session. I would like to remind the participants of tomorrow's program scheduled. So we
Shall I
will
stop
meet at
it?
this. Sure, ma'am. So we will meet at the same time at 5 p.m. Tomorrow, there will be 3 parallel sessions for computer science engineering, electrical engineering, electricals and electronic engineering, electronics and communication engineering, electronics and telecommunication engineering branches. The topic will be on e-mobility and hybrid electric vehicle, and the speaker will be Dr. S. Seetharamu, former Director Central Power Research Institute, CPRI. And I request all of you to go through the program catalog. Now it's a time to end our session. The end of one chapter is just the beginning of another. Read on the best part is always yet to come. Don't let the sun go down without saying thank you to someone and without admitting to yourself that absolutely no one gets this for alone. With these quotes, I am grateful to thank Dr. Kalpana Pichaimani ma'am for her valuable time. I extend my heartfelt thanks to the participants. Thank you all.
Thank you so much for giving me the wonderful opportunity to present my lecture on this particular this internship. Thank you so much.